Hi, this is Lance Culver and this is going to be a TyFlow tutorial. In this video, I'll be creating an electrical effect. It will not be using any scripting, but it does have somewhat more of an advanced setup. If you are a beginner, you are going to learn a great deal about TyFlow and how it works, but it'll probably take a few videos to get it all in. I'm going to try to at least briefly explain everything I'm doing because again, I'm gearing this towards newer users. It's not that it's all that difficult, it's just the setup can be a little confusing until you understand exactly how it's working, and then it's pretty simple. If you're more seasoned in TyFlow and you don't want to sit through a couple long videos, I'm going to edit this down into the quickest version possible. You can follow the link that's on the screen now or check the description for a link to that video. But I am assuming though that you have opened TyFlow before. Okay, so the first thing we can do, I'll go ahead and create a sphere. And this will be the object that emits the electricity. And then we can create a box, and this will be the object that our electricity strikes at. All right, now let's go ahead and create TyFlow object, and then open editor. So the first thing we're going to do is set up a bunch of particles over here on this box that can be possible strike locations for the electricity. So let's go ahead and add a birth operator into a new event. And we'll say all particles on frame 0, and we'll say like 3,000 of them. Then we'll go ahead and rename this event targets. And now let's add a position object and pick the box. Now let's add a particle groups. So if you're unfamiliar with simulation groups, the way they work, you can imagine we're going to be having thousands of particles coming into the scene, part of our electricity, and we want to be able to distinguish between these particles and those particles, and an easy way to do that is to place these particles on their own group. Let's just say simulation group 1. And so now later, when we want to go find one of these particles so we can target it, we can just simply search for particles that are on group 1 and then randomly select our targets from those. It's essentially a way of labeling or grouping particles to make them easier to find later. All right, next we'll go ahead and add a birth operator into a new event. And again, we'll say frame 0, but this time just one particle. And we're going to use this particle to spawn all of the other particles that make up the electrical streams. So let's go ahead and rename this event parent. And we want to place this particle in the center of the sphere. So let's go ahead and add a position object and pick the sphere. And because we want it in the center, let's change the location from faces to pivots. And also we want it to stay locked at the center of the sphere so that if we want to animate this sphere, the particle will move with it. So let's go ahead and add an object bind and then pick the sphere. All right, next let's add a spawn operator. Now what the spawn operator does, it will create a copy, an exact copy of the particle in the event that it's applied to. So I don't know if you can see up here, it says 2 particles. There was just 1 particle in here. If we shut it off, now there's just 1. So what we've done is with the spawn operator, it's created an exact copy of this parent particle, and it is now the child of that parent particle. And it is going to have the exact same position, rotation, everything, and all the data channels will be copied over to the new particle. The only difference will be it is the child of the parent. All right, and we're going to leave all the defaults as they are, but we will come up and open timing and change it from on event entry to frame. We're going to leave it on frame 0 for now, and that way we'll be able to work on frame 0, but I'll adjust this later so that there's no electrical particles in the scene as the simulation begins. But we will utilize frame skipping, let's say 5 for every nth frame with a 3-frame variation. So now what that's going to do is cause the spawn operator to continuously but randomly spawn particles. All right, so let's go ahead and create a new event. And we'll rename this event spawn particles. All right, I'll go ahead and change the display to ticks and then change the color so we can see it. And of course, right now we can't see it because it's in the center of the sphere. So let's go ahead and add a position object and pick the sphere. And so now if we were to scrub through, we will see that we're getting particles spawn on the surface of the sphere. And that's exactly what we want. Go ahead and hide the sphere. So now we can see here we have this parent particle, which is this brown one, and then we have the red one here, which is the spawn particle. Next, what we can do is go ahead and randomly target one of these particles so that we can create the stream. So let's add a set target. Now, if you're unfamiliar with set target, this is undoubtedly one of the most powerful operators in TyFlow. If we come up here under set target and select this drop down, you can see there's a number of ways of deciding how to choose your target. We're going to select by proximity. We couldn't go ahead and enable prevent duplicate assignments, but in this particular case, it's probably not going to have much of an effect because there's likely not going to be two spawn particles entering this event on the exact same frame, and that would be the only time that the set target could prevent duplicate assignments. Then go ahead and open target filters, and we want to search for particles that are on group 1 because again that's the group we set these particles on. This simulation can also use ray casting. Go ahead and select the drop down and rays must not hit, and then pick the box. What that does now is it takes the geometry of the box into account. Think of it as if the spawn particle can't see the target because of the geometry of the box, it cannot select it as a target. All right, now let's scroll down here under proximity and let's increase the radius to something like 90 or 100. And then here under neighbor selection, let's change it from closest to random. Now let's go ahead and drop in a resample operator. And you'll notice that nothing's changed. That's because the resample setting is on siblings and the spawn particle has no siblings in the scene. So if we were to change it here from siblings to target, you'll see that a number of particles have spawned in between the target and the spawn particle. Now, even though these are copies of the spawn particle, at the moment they do not have the same target. Even though the set target operator was dropped in before the resample operator, and they don't because by default the resample resamples the target hierarchy, which means instead of them all having the same target, the targets are resampled to the particle in front of each particle. In other words, this particle's target is this particle's target is this particle, and so on. But we want them all to have the same target, so let's just disable this setting. And so now each of these particles have the same target that was set up with this set target operator. Now to add some more particles, we could increase the subdivisions, and we may, but for right now, let's just lower the threshold down to 1. That's going to create a lot more particles for us to work with. And now let's create a new event. And we'll rename this event Bind Particles. Go ahead and hide this box for right now. And maybe shut these particles off. So I want you to be paying close attention to the colors of our particles. And that's going to let us know which event those particles are in at that point in time. And that's going to be one of the main things that helps you to understand how this thing works. Okay, so let's go ahead and add a particle bind. Zoom in here. Now when you're setting up binds, it's helpful to enable show bindings just so you can see where those binds are being created. And off first look, it looks like it's doing exactly what we want, but we're going to make some changes. First thing we can do is let's reduce the max binds to 1. And you might have noticed some of our binds disappeared over here. It's okay. Going to come on down here under family filtering, and let's change this to bind siblings. And then open family bind and enable bind to siblings and bind to parent. And so now if we were to drag through the timeline, we'll see that we're getting additional spawns. All of our streams are creating their binds, but there's no cross binding in between one another. So everything is set up exactly the way we want. So now the next thing we need to do is, of these purple particles, we need to separate out the very last particle from the rest of them. So let's add a property test. And then here under test type, let's change it to sibling type. And then you'll notice here under sibling index, we have a few options here of selecting particles. Let's select last and create a new event. Go ahead and change the color. And you'll notice that particle down here now is in this new event. I'm going to go ahead and rename this all particles. Okay, so let's take another look really quick what we have. We have the last particle, which is over here on the box in this all particles event. And then we have all these purple ones, which are in the bind particles event. And then we have the spawn particle, which is still here in the spawn particles event. So the next thing we're going to do is separate out a few of these particles here at the bottom So let's add a property test into the find particles event. And here under test type, let's change it to distance to target. Then we'll say if it is greater than 5 and change the channel to target, create a new event. Change this color. And I'll rename this event split particles. So now you can see the only thing that's different is these yellow particles now, which are here in the split particles event. So now what we want to do is basically divide these yellow ones in half. Let's add a property test here into the split particles event, and we'll change the test type to distance to target. If it is less than, maybe 55, and then change the channel to target, and now create a new event. Maybe we'll go back into this property test and lower this down to maybe 50. All right, that's good. Now we'll rename this new event lower particles. Okay, real quick again, let's take a look at what we have. We have the spawn particle, which is here in the spawn particles event. We have these upper yellow ones, which are here in the split particles event. These lower green ones, which are here in the lower particles event. Then we have these few purple ones, which are still in the bind particles event. And then we have this very last one, which is here in the all particles event. All right, so next thing we're going to do is randomly select a few of these green ones to create additional branches. So let's add a split operator into the lower particles event. Let's choose random and give it like a 5% chance. We may need to adjust this later because this could get out of hand. All right, but let's create a new event. And I'll rename this one branch particles and then change the color. All right, so let's take a look real quick what we have. Again, we have the spawn particle, these yellow ones that are here in the split particles event, the green ones which are in the lower particles event, and we have these purple ones which are going to be our contact particles here in the bind particles event, and then we have the last particle. Now we have these new red particles here that are in the branch particles event. And for these, we can essentially do the same thing we did in the spawn particles event. As a matter of fact, we can make copies of the set target and resample operator and drop them into the branch particles event. You'll see that new branches have spawned. And we'll make a couple adjustments, maybe come into the set target operator and reduce the radius down to, let's say, 35. Then we can see that this one particle up here did not spawn a branch. That's because it's too far away from the target. Raise this number to like 45. And also for these upper particles, we could randomly choose one or two of these occasionally to spawn a branch. So to do that, we could add a split operator here into the bottom of the split particles event. And then do the same thing, we'll say random, but this time maybe only like a 2% chance. And so we could just take a copy of this branch particles event, paste it in here next to this other one, then come into the set target and increase the radius, maybe 80, and then connect this to the split operator. And now none of them spawn, but that's because the random chance is so low. If we were to scrub through a little bit, at some point, we'll see here the very next one. That does leave us with a couple issues. We have new particles that have no binds, and we also have new last particles that have been spawned that we need to be keeping track of. To solve that, we can simply connect the resamples back into the bind particles event, and now those particles will cycle back through these events until there's no more opportunity to create any more branches. And that'll happen on the next frame. We'll see that new branches were created from the branches, and new last particles entered the all particles event. And then if we went through another frame, we'll see those new spawn branches also created a new branch. These last particles made it into the all particles event. All right, so this is essentially the bones of the setup. So hopefully you have a decent understanding of how we just built this thing up. And now we can work on its behavior. Let's go ahead and add an object bind into the all particles event. Pick the box. And we can select lock to surface, snap to surface. Maybe reduce the friction down to, let's say, 80% and then give it some kind of variation. So now we've just applied an object bind to this last particle. And so it'll stay trapped onto the box. If we were to scrub through here, we'll see that as these things spawn, the object bind is binding them all to the box. Problem with this is we're going to be bringing all of these particles, with the exception of the parent particle, into the all particles event. And so this object bind is going to interfere. For example, if we drop a send out operator into the bottom of the spawn particles event and connect that to the all particles event, instantly we have an issue. But what we can do is come up here to this property test, which is the property test that sends the last particles into the all particles event, and then open test action. And then here you'll see under data, let's enable save test value when test true, and let's create a channel here called last one. So now what this is going to do is whenever a particle tests true, which can only be a last particle, the property test is automatically going to assign it a data channel named last one and give it a value of 1, which in this case means it just tested true. Whenever a property test does a sibling type test, the only data it will return from that is either a 0, meaning false, or a 1, meaning true. If we were testing for distance to target, for example, and we enabled save test value when test true, the data it would save in this channel last one would be whatever the distance from that target is. But in this example, with a sibling index, it will only return a 0 or a 1. Let's go back into the object bind. And then open filters, enable filters, and let's add a custom float. And then we'll say if it is equal to 1. And now let's change the channel to last one. Okay, so now what's going to happen is the object bind is going to ask every particle that comes into the event, do you have a data channel named last one with a value of 1? And now, so out of all the particles that will make it into the all particles event, the only particles that will be affected by the object bind are going to be particles that tested true via this property test, which again can only be last particles. And now we can do the same thing with the spawn particle. Let's add an object bind and pick the sphere. And then we can say lock to surface, snap to surface. And you'll see that just messed up our last particles, but let's not worry about that right this second. But we will maybe reduce the friction down to 80, give it a variation, and come here, open filters, enable filters. Let's add a custom float. And we'll say if it is equal to 1. Create a channel here called spawn. And that appears to have fixed it, but it's not actually applying to any particles now because there are no particles in the simulation with a data channel called spawn with a value of 1. But if we come up here and select the send out, open test action, save test value when test true, and then add that channel spawn here. And so now this object bind will only apply to particles that are sent from this send out. The only particles that can be sent from this send out operator are these spawn particles, because every other particle is created by this resample operator and sent immediately into the bind particles event. When a spawn particle passes through this send out, it will automatically be assigned a data channel called spawn and given a value of 1. Take a copy of the send out and drop it over here into the bottom of the bind particles event. Let's open test action and then rename this channel to contact. And now the only particles that are going to be sent through this send out operator are going to be these last few here at the bottom. I know that these other ones, all the branches are purple right now, but on the next frame, these property tests are going to send most of those particles to the next event. All that will remain are these few at the bottom. I'm calling these contact particles, but they're basically going to be particles at the end of each stream that are more fluid than the rest, and that'll help to create the illusion that it's connecting to an object. Go and connect this to the all particles event. And so now we can add a surface force and pick the box. Let's go ahead and reduce the force down to maybe negative 0.09, which will actually repel the particles. Could also give it some variation. And let's reduce the distance effect, maybe 1 with a fall off of 1.5. And now let's open filters, enable filters, add a custom float. Then say if it is equal to 1, and change the channel to contact. So now this surface force is only going to apply to these red ones here at the bottom. And what it's going to do is help push them away, which can make an interesting effect. And then next we can go ahead and make a copy of this send out and drop it into the bottom of the split particles event. Then open test action. And let's change this channel here to spread. All right, we can actually make instance copies of this send out and drop it into the bottom of these other events. And then connect all of them to the all particles event. All right, so now what we can do is add a spread operator. And then come down here under noise and increase the strength. Start off, let's say maybe 3. Reduce the scale way down, maybe 0.15. It's having an effect over here on the particles. And come up here and open filters, enable filters, add a custom float. And say if it is equal to 1. And then change the channel to spread. And now open timing and change it to now open timing and change it to continuous. Let's go ahead and add a slow operator. Increase it to maybe 30%. Take a copy of this surface force, drop it beneath it here. Increase the strength a little bit, maybe negative 0.075. Now let's increase the distance to 8 with a fall off of 10. And now open filters and change the channel from contact to spread. Now that'll put a little force against the particle streams and maybe also help keep them from intersecting the box. And also add a collision operator and pick the box. And let's change it to collide with front faces. That way if a particle does get inside the box, it can make it out, but it won't be able to make it back in. We could also add a force operator. Change the noise type to curl. Increase the strength, maybe 0.06. Reduce the scale down, say 35. And shut these ticks off. Okay, I think it's starting to get somewhere. Let's add another force operator. And again, we can change the noise type to curl. Give it a little bit of strength and reduce the scale, maybe 30. And then open filters, enable filters, add a custom float. Let's say if it is equal to 1, then change the channel to last. Hide this. Let's go ahead and come in here to the surface force and increase the strength a little bit. Maybe help push those particles out of the geometry. All right, let's go ahead and set up deleting these things. There's a few different ways to do it, but I think for this simulation, let's add a particle bind into the spawn particles event beneath the resample. And then let's enable show bindings. And you can see it created a bind in between the spawn particle and the first child, which isn't what we want. We want the bind in between the spawn particle and the parent particle. So let's come down here under event filtering and change it to this event only. And now open family bind and enable bind to parent. Now if we scrub through, we'll see that that's the only binds being created is in between the spawn particle and the parent particle. So now let's come back up here to the top under bind ID. Let's change this from 0 to 1. All right, so now what we can do is let's add a delete operator. And then open filters, enable filters, let's add a custom float. Say if it is equal to 1, and then change the channel here to spawn. And now let's open timing and change it from on event entry to event age. Let's say 20 for the initial frames with a 10 frame variation. And now somewhere between frames 10 and 30, the delete operator is going to delete the spawn particle, which will delete this bind in between the spawn particle and the parent particle. Let's add a property test. Change the test type to binding search. And then say if it is less than or equal to 0, add that unique ID that we created here. And now let's increase this depth enough so that we know TyFlow will search deep enough up the chain of binds to find it. And now let's create a new event and then add a delete operator into this event. And now if we scrub through, turn these ticks back off. All right, so let's take a look at it real quick. To control the noise level of the particles in the spread operator, we could increase or decrease the strength. So if we were to lower this down to 1, we're going to get a lot smoother of an effect. Whereas if we were to increase it, we will get a lot more noise to it. And also adjusting the force values will also affect the way it behaves. That's going to make a good stopping point for this. Please follow the link that's on the screen now for the next video or check the description. But I really do appreciate you taking the time to watch. And I realize if you're new to TyFlow that this might be a little overwhelming. So if you're having any issues at all, please do leave me a comment. Be sure to watch the next video because we're going to add some more functionality to it, adding additional objects, distinguishing between those objects. If you like the video, please hit the like button. And if you haven't done so already, please subscribe. I would really appreciate that. I will see you in the next video. Thanks again.